Welcome everyone to GeoHug. So I'm very excited. We've got Dan Macklin joining us today. But before we do get stuck into today's session, I would like to take this time to acknowledge the traditional lands which we're all coming from today. I live on the beautiful lands of the Gadigal, of the people of the Aurora Nation, and I'd like to pay my respects to the elders past, present, and future. And yes, I am very excited that we've got Dan Macklin joining us today. So Dan is the General Manager of Exploration for Evolution Mining, working across the company's greenfields exploration portfolio in Australia and Canada. And today he'll be sharing some icy adventures, glacial learnings, and fun reflections from 2.5 years exploring around Red Lake in Northwest Ontario. So it is going to be a fantastic session. I hope you all enjoy it. And yes, thank you so much, Dan, for joining. It's awesome having you here today.
No worries. Really glad to be here. Hi, Jess, and hi, everyone.
Before we do get stuck in, I was really curious what made you become a geologist to begin with.
It's a good question. It's probably not as romantic story as you might hear otherwise on GeoHug. I guess first and foremost, I grew up in New Zealand, and growing up around the Southern Alps in New Zealand, and having that as your playground, you sort of naturally take a general interest in geology. But it was actually my sister who she's obviously from New Zealand too, but she was a field technician over in Western Australia, and she was the one that said, well, maybe study geology because I'm meeting a lot of geologists. They do lots of outside work, and I think you'd really enjoy it. And she was right. So it was probably more a credit to my sister that got me into geology.
I love that. That is amazing. And yeah, and you did recently spend a few years in Canada. So I'm very excited to hear this story. Yeah, I bet you're missing it a lot at the moment.
I am. Yeah, and actually, I'll give you an excuse up front here, Jess, and everybody else, just in case I'm a bit incoherent or I start drooling. I'm actually in Canada now, which I think somewhat appropriate for what we'll talk about today. But it does mean I think part of my brain, or certainly my body clock's still back in Australia. So I might be a bit disheveled today. So just bear with me and give me a prod if I start drooling.
No, well, I'm very impressed with the commitment of sticking with the schedule with
Yeah,
all your
that's
travel
right.
plans. So thank you so much for joining us today. Yeah, and everyone, if you want to keep using the chat, I'm just promoting you up as panelists, so you're welcome to come through. We'll open up a good discussion at the end. You can jump off mute and chat directly. But yeah, thank you so much. Let's get into it.
Excellent. Well, thank you, Jess, and I really appreciate the opportunity to contribute to GeoHug. I've been to a few of your sessions, and I really like it, and enjoy what you're doing with GeoHug, bringing people together to share ideas, and very happy and excited to contribute to it today. I only hope that people can get something out of this as I share some of my time and learnings from working and living around Red Lake. So today's talk is centered on an orientation survey that we undertook as a team on an entirely submerged and buried orogenic gold deposit in the Red Lake area. So what we wanted to do in this particular area was understand and optimize the best techniques that might detect and help us find future ore bodies, knowing there's a bit of a challenge in the Red Lake area around glacial cover and glacial lakes. I'm going to speak a lot about till sampling today, and a lot of our colleagues and friends joining from Canada or other areas where there's been recent glaciation, would know that this is a very old technique, and hence the reason why I selected the title of the presentation today, which is Old Techniques, Unearthing New Search Space. And the reason for that is, one, I'm a big fan of doing what works and what works. And if you know that there's a technique out there, it doesn't matter if it's not the new sort of whiz-bang type technology you might apply otherwise. If it hasn't been done before and it works, we'll go out and apply it. And interestingly enough, at Red Lake, which I'll talk about as we go today, there hasn't been much systematic basal till sampling done, in particular on the evolution claims. So we saw that as a real opportunity. If you're going to get something out of today's talk, in addition to some learning around till sampling, if it is new to you, I really hope what you might get out of it is the importance of optimizing and understanding the exploration technique you might apply in a given setting before you invest further and potentially waste time and effort or go down some rabbit warrens. So we'll talk about that in the orientation context today. But secondly, what I'd love to pass on to you all is the excitement and adventure of going to different areas and having the opportunity to explore in different settings. There's a saying out there, and I've heard it a few times on GeoHug, about the geologist who sees the most rocks wins. Well, I'd make a small extension to that. And I firmly believe that if you're an exploration geologist and you get the opportunity to explore in a range of different settings, I think you will win as well. And I can vouch for that for my time around Red Lake, where I know after 2.5 years there with the team on some really cool rocks in this type of setting, I certainly feel like I learned a lot and came back to Australia a much better exploration geologist as I continue on my journey and my career. So the opening cover shot here is an interesting one. I took this photo. This is right bang smack in the middle of the orientation survey that we'll be discussing today. So it's taken off East Bay around Red Lake. So we're sitting on ice. We're sitting on a lake body here. That thing in front of us is a flood pump. So you get a fishing auger, and you drill through the ice and you drop that pump down through the ice, and then you actually pump water up on top of the ice. Obviously, that freezes against the areas that are exposed to the nice cold climates there, and that's how you build up your drill pad and your drill tracks, so that eventually you can take heavy machinery out onto the ice safely and stably to complete the drill program. Don't be fooled by the steam. I believe from memory on this particular day, you're talking -20, -30, so it's a really cold February day out in northwest Ontario, and very clear skies. They're always the coldest days. And I'd estimate, and I'm only guessing, that water's probably, I don't know, 5 or 10 degrees, if that. So the steam, although it looks nice and hot and steamy, is really cold against really, really, really cold. So don't be fooled. It's not warm. So, excuse me. Forward-looking statements. If you've joined to hear more about Red Lake and Evolution's activities there, operations, performance, mineral resource base, any of those sorts of things, you'll be severely disappointed. I'm not covering those bits today. I'm purely speaking about some technical exploration ideas, as well as this orientation survey. But by its very nature, some of the things that I'll discuss today are forward-looking statements. So I'd encourage you all to take the time to look through this slide when it's uploaded. But I certainly won't be going through it in detail today. Importantly, before I get into the presentation, I'd really like to acknowledge the land which Evolution Mining operates around Red Lake. So it's Treaty 3 territory, and it's the traditional lands of the Glacial and Wabauskang First Nations. And those First Nations are partners in everything we do around Red Lake, mining as well as exploring, and we're really grateful for the relationships and the land that we operate around in that particular part of northwest Ontario. So before we go -30, ice drill rigs, glacial till, all those sort of wonderful things that I was able to experience in northwest Ontario, I wanted to take you to a bit more of my comfort zone and work history and give you, I guess, some ideas about me arriving in Canada, deeply confused but willing to learn, but some of the experiences I'd had along the way. Specifically, I want to take you close to Kalgoorlie, about 45 minutes driving to the south to the Kambalda area. And obviously Kambalda is really well known for its nickel mineralisation, but it's also very close to the St Ives gold camp, which is currently owned and operated by Goldfields Australia. Again, I was really lucky to work for a couple of years at St Ives, and it was actually the first place where I was able to get my nose properly on an Archean orogenic gold camp. And so it was really impactful for me working at St Ives, because I started to learn more about these mineral systems and what's important for helping and working to try and find new lodes and sustain production goals. When I think about St Ives, it's a true gold camp, and I've got an image on the right here. Up here is Red Hill, where some of the original gold was found, and it's 33 odd clicks down to Junction, which is another sort of larger mine in the history of St Ives. And in between, along that central corridor, there's a true camp of gold deposits that have contributed into St Ives being a gold operation. There's not really one large production centre and a few satellites. It's more like moderate to small centres plus the satellites as well. And what that has meant over time is that periodic exploration success or discovery success has been absolutely paramount in sustaining St Ives gold mine throughout its history. And a couple of the key aspects that I felt I learned a little bit about when I was working at St Ives as part of this success is challenging search space and working your way into new search space at the appropriate times to help try and find new gold deposits. And when I think about search space, I think about geological search space, so that's exploring in new rocks. But I also think about physical search space, so that's exploring in new areas that might not have been explored before with techniques that are either being developed or help open up particular places for you to get the drill hole in the right spot. At St Ives, as well as the broader goldfields area, a lot of exploration has been done in fractionated dolerites, and for good reason. They're fantastic host rocks, they're chemical and structural traps for orogenic gold, and over time they have given up fantastic exploration success and produced a lot of gold in the goldfields and St Ives area. But by the very much, I guess, that idea being so strong in the goldfields has meant that those dolerites over time have become very mature, and there's been a lot of exploration done on those dolerites. And at St Ives, more recent exploration success has actually been exploration geologists pushing out into new rock types, and lo and behold, in these orogenic gold systems, you can find gold pretty much in all parts of your stratigraphy. At the same time, the original gold at St Ives was found up here at Red Hill. There was some prospector workings down at Delta Island down here, as well as Victory. And then off the back of that exploration success through the 80s, 90s, 2000s, and until today has come throughout this camp. But it didn't take long for exploration geologists at St Ives to work out that they had to get onto Lake Lefroy, that if you've got gold at Red Hill, you've got gold down here on the land around this Victory area, that getting on Lake Lefroy, there must be gold-bearing structures on there. And lo and behold, through Revenge and other discoveries beneath Lake Lefroy, a lot of the recent exploration success has come from that particular part of the world beneath the Salt Lake. So when I left St Ives, I had two key ideas in my head for Archean orogenic gold and looking for gold deposits. Make sure you're not too host rock dogmatic. These deposits will form anywhere, but also push into new search space and go where perhaps prospectors might not have been able to go and use conventional methods and find the easily found deposits. So that was something that was quite impactful for me for my time there. So we'll now leave St Ives. We'll shoot across the Pacific and where I am now, so in Canada, and specifically take you to Red Lake. So Red Lake's in Ontario. I've broken out the province of Ontario here. People who are less familiar with the province probably know Toronto. That's the white dot down the southeast here near the US border, and it's the largest population and largest city in in Ontario. But Red Lake's bang smack on the other side of the province. So it's actually a long way away from Toronto. And in fact, only a 5.5, 6 hour drive from Winnipeg, which is the capital of Manitoba. Geologically on the right is the Superior Craton, which, like other Archean cratons around the world, whether it's Australia, Canada, Africa, South America, wherever they are, has actually evolved in a remarkably similar way to some of those other parts of the world, including, say, the Yilgarn in Australia. And the Superior Craton, when you compare it to the Yilgarn, have evolved very similarly to that area of West Australia. And actually, in terms of the metal endowment for orogenic gold is very similar as well, albeit with some intricacies in terms of difference. If you want to be in the eastern goldfields equivalent of the Superior, you want to be down here in the southern Abitibi, around your Timmins, your Kirkland Lakes, your Val d'Ors. That really is the home of orogenic gold and the Superior Craton. We're not there. We're on the western margin over here in the Rice Lake, Pickles Lake, Greenstone Belt. And I think most people, when you talk about Red Lake in terms of orogenic gold, what springs to mind is some of the incredible grades and fantastic discoveries that have been made at Red Lake over time. So that's where we are. We're on the western margin of the Superior Craton. I guess a little bit more about gold in Red Lake. Red Lake has a really deep and rich history in terms of gold mining history and exploration success. Not too dissimilar, again, to other well-renowned gold camps throughout the world. The map here on the left here is simply a photo of the Red Lake Mining District, and it's taken at the Red Lake Regional Heritage Centre. Red Lake's at the end of the road. It's on the 105 in northwest Ontario, but if you're ever passing through, make sure you get to the Red Lake Regional Heritage Centre. It's a fantastic resource that talks about the history of the area, both in life of gold mining, but other aspects that are really key to Red Lake as well. But this poster here shows, a range of deposits and areas that have been mined and found over time around Red Lake. And the interesting bit here is that most of the original mining was actually done around the Red Lake town itself. So where I'm circling here, the Howie Bay Gold Mine, Hasaga, Buffalo and whatnot, as well as out at the western end of Red Lake in this area out here. And it wasn't actually until we're into a decent, chunk of the mining history around Red Lake that John Campbell, who I've got a photo of on the right, panning gold on the edge of the Barmer Lake, actually made his way out to this particular area near Barmer Lake and started trenching to the base of cover and was essentially prospecting gold grains back to iron carbonate veins. And lo and behold, he gets the drill rig in there, and that eventually is the discovery of Campbell, and then quickly to the south, the discovery of what was called the Dickinson mine, but has had various names through time, which are essentially the same mineral system, and went both going into production in the late 40s and still in production to today. The reason I mentioned that is John Campbell digging to the base of cover and prospecting and looking at gold grains is essentially a lot of what the talk will be about today. So, as I mentioned, very old techniques, but very effective. So here's a geological image of Red Lake, grossly oversimplified, and in many ways geologically it's blasphemy because I have taken a lot of detail out of here, but it's for a very specific reason. So the evolution claims in our JVs are there as they stand on the current day. And then what I've made green here is the Barmer assemblage, which is Mesoarchean in age, some of the younger volcanic rocks in the area, and predominantly mafic volcanics, but has got a suite of rock types within the Barmer assemblage. And over time, when John Campbell went and did his prospecting and he found Campbell, but as well as Koshner, McFinley, other parts of the mineral systems that we own today, have predominantly been found and produced gold in the Barmer basalt and within what's called the Barmer antiform. If you take your mind back to what I described about St Ives and mature search space, what I've now done on this map is I've overlain all the drill holes as well as the gold deposits. And you see that most of the exploration, certainly on the evolution claims, has been done predominantly within the Barmer assemblage. And that's becoming quite a mature search space for us. But what are these other rock types? Well, in grey, I've got sedimentary dominated packages. In blue, I've got non-Barmer volcanic assemblages, and generally younger Neo-Archean, so sitting above the Barmer. And then in pink, intrusions and granites. And what certainly I first noticed when arriving at Red Lake, and as a team when we sat down about and discussed how we're going to do regional exploration as a group, we now own Red Lake, what are we going to do? I think the opportunity we all aligned on was pushing out into these new rocks. Again, orogenic gold camps, you don't have to be too dogmatic about what rock type you're in. And there was a huge opportunity for us there. I think this has been really well underlined and affirmed by the 2018 discovery of what was called the Dixie Project by Great Bear Resources. It's now the Great Bear Project, owned by Kinross. And it's a fantastic bit of work, which is a significant discovery in felsic rocks. So they're not mafic. And they're younger. And I think the day that Dixie was found and they did the fantastic work down there to do that work, a new rock came to town in Red Lake, and I think has really rejuvenated exploration efforts in the Red Lake area. So that's all about exploring in new rocks, but what about that physical search space and increasing our ability to search in new places? So this is the exact same field of view. Here's the 105, working up to the town of Red Lake here, town of Barmertown, town of Koshner. So these are the main towns in the Red Lake area that are there, and many people living there work at the mine or in the area. And the first thing you see when I put the aerial photo on now instead of the geology is that there's a significant amount of lake cover here. In fact, 30% of the evolution claims are concealed by glacial and modern day lakes. Not only that, once you get on the land, and it's quite surprising when you get there, there's not a whole lot of outcrop. In fact, there's quite extensive glacial deposits that stop you going up and kicking and licking outcrops as you might expect in an area like Red Lake. So immediately in terms of geomorphology, again, looking back on that time around St Ives and opening up new areas and developing techniques to help explore systematically where people might not have been able to explore before, the juices were flying as a team when we just started to discuss how we develop our exploration toolkit, which is exactly what I want to talk about now. So as a group, we sat down, as I mentioned, I arrived early 2021. We were going to do more regional exploration, and we are doing more regional exploration around Red Lake, but how do we want to do it? And what are we solving for? So what we wanted to be able to achieve was to go out and screen beneath glacial cover, because most of the land is cover, as well as the shoulders of lakes or lakes where possible as well. We didn't want to just go up and drill, just put a diamond drill into, say, a magnetic target or geophysical target. We wanted to be able to build targets up systematically to understand where we wanted to be first and really hone where our deeper drilling might go. We were interested in, but needed a lot of education in glacial dispersion. But I was really interested in knowing whether glacial dispersion was actually more effective in the Red Lake area than hypogene or the fresh rock signature, and what was the most effective sample medium. And as we set out on this journey to do more regional exploration, we also wanted to make sure that the right anomalies triggered our interest. I mean, this is a gold camp. You're going to get a lot of anomalies. What level of anomaly will get us get us potentially very interested? But there were some considerations we had to make around tackling these problems. I've just arrived from Australia, and most of my working background had been in Australia. So I had next to no experience in glaciated terrains. Lots of experience in soil sampling and lag sampling, geological mapping, those sorts of pieces, but almost no experience in this type of terrain. At the same time, we had an absolute fantastic exploration team at Red Lake, but most of that group, leading up to the time where we're going to do some regional exploration, had predominantly worked close to the mine. They knew those mineral systems back to front. They knew what was interesting down in fresh rock, but didn't have a whole lot of experience pushing out and doing things like till sampling or stream steer sampling, whatever that might be. So we had limited experience of how to attack this type of setting. We knew that the glacial history was important, and we wanted to learn more about that. And around this time, we actually got connected with a fellow called Don Cummings, who's a consultant sedimentologist. Francois Robert was actually the person that connected us with Don. And that was critically important because Don was actually able to come to site, do some workshops with our team, and start educating us on that glacial history of the area. And in fact, down the bottom left is some material with the references below that Don put into his training package for us. And what you see here is 20,000 years ago, what North America looked like during the glacial maxima. So here's the Canadian border, somewhere underneath here. Here's the Laurentide ice sheet, which basically covered, let's call it 90% of Canada, and sort of the northern portions of the US as well. Well, when you look, I guess, simplistically at the glacial remnants that are left behind from the Laurentide ice sheet, this is what Canada looks like today. And if you're going to go out and do regional exploration, you absolutely need to understand your glacial history. So getting Don involved early was really important to us. And we started to learn what we should be careful of, tricks for old or young players, and off we went, starting to think about, I guess, sampling in glaciated terrains. Some of the concepts that started coming to mind, on the right here is an idealized model for a dispersal trail. So you've got an ore body buried in the country rock here. We've got a glacier that's moved over the top of that ore body and has developed a chaotic sediment at its base called a till. And it's sampled parts of that ore body and actually left parts of it in the till. With the concept being, if you go and detect elements of the ore body and work your way back up the dispersal train, you'll find your way to the ore body. And that, this is old hat to some people, but where we're getting our heads around this. So what we decided to do is we had to learn a little bit more about this for ourselves. And I still, to be honest, wasn't that convinced that dispersal trails or trains would be necessarily more effective than the footprint and the country rock around these deposits. And it just so happened at this time, and it absolutely wasn't the reason for the acquisition, but it was around this time that we acquired Battle North. And with that, we acquired, and being somewhat opportunistic as exploration geologists, we acquired the McFinley mineral resource, as we call it, which is on East Bay over here. So this is the same image I showed before with the towns, but here's East Bay. And zooming in, that's the McFinley mineral resource, desurveyed and projected up to lake bottom. And we realized, well, we've got a really cool exploration lab here. Why don't we go out and test some of these techniques before we invest more widely in the region? We actually did go out and do some of this work around Barmertown and the Barmer complex too. But the focus of today's talk will be about the work that we did on the ice here at East Bay. So in terms of methods, what we determined very early on for this orientation study is that we wanted to do this on the ice. The team did have reasonable experience drilling on the ice, and we decided not to do this in the summer on barges. What that meant was a huge safety and planning exercise to develop 11 kilometres of ice roads, as well as the drill pads to support the orientation study. We purposely chose very early on to use sonic as our drilling method. That's for a couple of reasons. In our sonic drill rig, in terms of its environmental impact, we're not pumping high pressure air down to the lake bottom or fluids like other drilling types. And we wanted to have as little impact on the lake bottom as we could, like we do with all our exploration activities. But at the same time, what sonic does is it gives you full core recovery through the unconsolidated material as well. Remembering we're on a learning journey here, so us seeing all the lake sediment, the glacial muds, clays, the till, and getting a good look into bedrock, because we're drilling 1.5 meters into bedrock as well, was critically important to us. What we then did, if we did strike till, well, then great, and we had enough of it, we'd send it off to overburden drill management. They'd prepare a heavy media concentrate for us and do some gold grain analysis, which we'll touch on soon. But we also did multi-element geochemical analysis on that HMC, as well as a fine fraction split, as well as fire assayed everything. So we kind of threw the book at testing out different mediums, different techniques for what part of the holes we were sampling and what was interesting to us. So we spoke at the start. That's the flood pump, the nice steamy warm conditions there in -30. This is what you would have seen on East Bay in that winter. Out with the snow machine there. This is our field techs getting ready and pegging holes and getting ready to go drill. And that's the Bort Longyear sonic drill rig that we used down the bottom right there in action on the orientation survey. Here's a little bit more around the drilling. So on the left there, it's obviously, this is from a GIS, it's from the summer, it's not when we were drilling. But again, McFinley Peninsula, the ore body here, and then the orientation grid that we targeted, mainly down ice to test the dispersal trail, but also going up ice to test the hypogene signature, as well as make sure we closed off the head of that trail if it was there. If it's blue on this image, we got till, or we got enough till to develop a concentrate and do the gold grain analysis. If it's black, we didn't. We essentially went from glacial fluvial gravels and sands straight into bedrock. On the right, here's a really cool image. This is actually the drill program in action. So here's the ice roads that we had to flood. The nice yellow ice is because the lake water, when it comes up and you flood it up, is yellowy and brown with the tannins. So it really does contrast with the white snow, but that's all flooded ice that we had to flood over a series of weeks to have enough ice to go out on the lake. This is a diamond drill rig here. We were doing some near mine targeting around McFinley at that time, but here's the sonic drill rig working its way across the orientation grid. The people flying this drone are actually right here. There's a truck here and then they're down there. So it's a pretty cool shot, and I think really signifies the body of work that went into successfully completing the orientation grid. So what do we see in terms of rocks? Well, here's a good, I guess, cross-section in terms of the sonic core boxes of what we saw down hole, and it really does typify the glacial stratigraphy for most of the Red Lake area. And that's summarized on the right here in a schematic log or strat section as well. So the organics here is essentially the modern day lake material. And to be honest with you, a lot of that's goose poo. There's a lot of geese, whatever you might call them, that fly around Red Lake and live in this area. And East Bay is known for having a lot of geese around. About here, you get into the glacial fluvial type material. So this is actually remnants of that glacial period. So we work our way through these sands and gravels. And this is a beautiful type hole because we break here where we've got the flagging tape and we go into till. So a nice polymixed, poorly sorted chaotic type sediment that sits right on top of fresh rock. So if we work our way through those 3 or 4 meters of till here, we go into bedrock, and I haven't got it here, but there's another couple of meters of bedrock that we drilled through. Now, the importance of that is we know it's a basal till. And in different parts of Canada or different areas, you will have different generations of glaciation or glacial advances and recessions, and you will get tills on top of each other, and that can be a bit more complex. What we've learned through this orientation program, but also through working our way through the region, is there's only one till, and it sits on the fresh rock. So once you're on it, you're in your basal till, and there's a zoom in of it there. When we get assay results in commas from ODM for this material, we essentially get a count of the gold grains. So here's some of the results that we got from the program. These are actually from the orientation program we undertook. And what ODM also did for us is they characterize it by morphology. So if that gold grain is pristine, it's been torn up, but it hasn't moved far, you're pretty confident it's probably within 100 meters of where it's been torn out of the country rock. Modified, started to move a bit, started to abrade a little bit rounded, but probably within 500 meters of where you find the gold grain. Whereas reshaped, has spent a bit of time in that till trail and has been rounded and abraded, and much like a river pebble, has traveled a long way. And when that occurs, it's kind of anyone's guess where it might be from. So lots of gold grains that are reshaped is much less exciting than perhaps a few less gold grains that are pristine and locally sourced. So there's a little bit more about the technique there. But what did we find? So here's the dispersal trail. So again, we're back looking in plan view at a summer shot because it's GIS, but this is the McFinley Peninsula. Here's the ore body here. This is the mineral resource, and we know ice flowed to the southwest over that mineral resource that's submerged beneath the bay. And we have a really beautiful, well-vectored dispersal trail that really pleasingly, the peak gold grain anomaly, 524 grains, which was predominantly pristine, but we won't go into too much detail on that today, is right bang smack on top of where we'd expect to see it based on where we know this mineral resource is. Not only that, on this western margin of the dispersal trail, it goes from 524 grains, 169, 142, there's a 68 here. By the time we get into this area, it's dropped right back to background, and perhaps the orientation grid is a little bit limited by the peninsula here. But what excites me as an explorationist for this is it's well vectored, it's very distinct, there's zero doubt. In these results, we'd go drill a hole. What you also see is a bit of a bifurcation in the development of till, which perhaps talks about, I guess, maybe something around the glacial sort of macro topography here, because there's no till development here along strike from the deposit, but there is down the western margin of the bay. And what you actually see there is a really long and thin, but still quite significant dispersal train in terms of gold grains. That really is limited by the furthest south we drilled. So there's quite a long, thin component to this dispersal train as well. But again, vectors up quite nicely to McFinley. So here we go. We're learning, well, I was learning a lot here. This is a great technique. And it really is pointing to where you'd want to site a drill hole if you're looking for these types of deposits in the region. What about bedrock? So this is the assays from drilling 1.5 meters, 2 meters down into the country rock. I'll put the dispersal train on here just, for relative context. And what you immediately notice is it's a peak of 370 ppb gold. So really low level gold in the bedrock. This is, for those who have explored and deeply weathered or in regolith like I had previously, this is the ultimate strip profile. I mean, you've had a bulldozer here come over and just grind off any material. It's all fresh, and you go from the glacial cover straight into fresh rock. So I guess not a huge surprise. But when I look at this compared to the dispersal train, I go, well, if I only had these results, a peak of 370 ppb gold, essentially at end of hole, and it's a bit noisy like this, I'd struggle whether we should drill any holes here, and if we were going to drill, where we'd drill them. So immediately, I guess the learning was gold grain analysis really seems to do the trick in this terrain. We'll have a look at some of the other elements, and we're not going to walk step by step through those elements just in the spirit of time, but we'll look at a couple of key ones, both from the multi-element from the heavy media concentrate and the fine fraction. And on this slide here, arsenic up the top, antimony down the bottom, And for us, again, when you look at it, and we've applied this relative to other samples in the area as well as within the grid as it is here in terms of normalization. And you look at it and you go, well, nothing really matches that dispersal train. And again, I look at it and go, well, I'm not sure where I drill or get excited about. There's no real vector to back to where we know that ore body is. So the gold grain analysis wins out on this as well as here for the tungsten and the sulfur. What I would say for the sulfur, for the I guess the eastern part of that dispersal train here, there is a nice or a reasonable correlation there, which is not too surprising. Sulfur development and pyrite is quite common at McFinley, but again, much less compelling and not as well vectored or distinct as the gold grain analysis. So what are our learnings? And I know I've raced through this quite quickly, and we've got a host of learnings. And in fact, some of those learnings we'll keep to ourselves because we have kind of optimized how we want to do this type of work. But the image on the left there, I guess, summarizes our key learnings from this work. And Alan Bieber, who was one of the key people who helped pull this work together, described to me that the other day that this image is his Mona Lisa. This sort of culminates all that hard work and what we took away from it in terms of our exploration around Red Lake. So here's our exploration model. If we obviously truly believe now that targeting till and doing gold grain analysis and chasing up dispersal trains or meaningful dispersion trains is the most effective technique in this area in the Red Lake region. So we've got ice flowing this way, and we've got lots of sands and muds at the surface. And we've got much more confidence now in terms of when till might be buried. Well, then it's drill for till, whether that's an auger, sonic rig, whatever that might be. There's no point sampling up the top of the profile here like some previous operators had. You need to get to till. You need to have confidence you're in basal till, and then you can truly understand with what you're dealing with. The beautiful thing about Red Lake is we know there's one till, and actually that till is exposed at surface a fair bit as well. So far more effective and well, certainly more cost effective than drill for till is getting out and digging in the dirt, which is some of our team members doing this over field seasons out in the Red Lake region as well as our other greenfields projects. So going out, looking for that nice gritty till, augering down, taking a fine fraction sample as your first sweep, and then coming back for an HMC and gold grain analysis. Once you've got confidence, you've got an anomaly. So in terms of learnings, gold grains and till really do present distinct anomalies, especially when compared to fresh rock manifestation of gold in this particular area in this setting. Gold grain analysis is king. You want to do that, but it's very expensive. And actually you can sweep through an area pretty quickly with fine fraction assays and then come back and do your grain morphology and gold grain analysis to help tighten up your drill target. I think importantly, the McFinley dispersal train, as well as other documented dispersal trains, I tend to be quite long and thin. And what that means is your inline spacing has to be quite tight. You don't want to let one of those slip between your drill points or where you dig it in the dirt. But between lines, I think you can be quite coarse and probably be a bit more aggressive with how you space lines. The fourth point here is a really important one for me. And philosophically, what we set out to do here was really grow confidence in what we wanted to do as an exploration group in terms of developing our exploration toolkit. And what I can say is that the team is really confident in doing that now. They can read the ground, they can apply the technique that they feel is most effective for screening for meaningful dispersal trains. And we weren't in that place when we started this journey and we were staring at some of these anomalies. Surprisingly, on the evolution claims around Red Lake, very little of this has been done. I think I touched on John Campbell applying this back in the prospecting days, and there's some groups out in Canada applying this technique and doing really well off it. But around Red Lake, little's been done, especially in those younger volcanic rocks. So there's a real opportunity for our Red Lake exploration team to apply this technique, and as the title suggests, open up that new search space. And I think importantly as well, we're not just doing this at Red Lake, we're actually leveraging our learnings here. And right now we've got crews out there doing this style of exploration at our other greenfields projects in Ontario as well. Before I close out, I did think it was only right to, I guess, provide some really fond reflections of my 2.5 years living and working around Red Lake. I can speak professionally today about some of the learnings that I had. And for me, it was a real career highlight to be able to go to this part of the world, beautiful part of the world, beautiful rocks and great team. And, I can also say for my family is that we greatly enjoyed working and living in the community here too, and really enjoyed our Northwest Ontario time. There's some great fishing here up the top left. Here's some Northern Lights. So the evolution sign in front, the Northern Lights, and we got some fantastic shows of this just off our back porch, which is just amazing when you see it. Here's the Red Lake Exploration team. So this is our core shack team, our discovery group, drill services, our near mine exploration group, and just a really highly engaged set of individuals who I learned a lot off and really enjoyed working with. I've got really fond memories of working with Francois. So Francois Robert was, a bit of a mentor for us at Red Lake. We were lucky enough that our old general manager Rex connected us with Francois, and he actually took us around the southern Abitibi with Howard Paulson, who's down here as well. And, in terms of, I guess, geological highlights, it doesn't get much better than that. Francois Robert and Howard Paulson in the southern Abitibi. And I know the whole team got a lot out of that. I've got a picture here with my wife and our boat out at West Red Lake. So as I said before, we personally really loved working here. And then I've got another photo here of, I had to sneak a photo of Alan here because he's provided a lot of the material that's gone into this presentation, Al Bieber. But that's us going to visit one of the mines on our Explorathon trip as well. Some acknowledgements, the entire Red Lake exploration team for just being open-minded and willing to learn. The people that led this work, they know who they are, but, they deserve acknowledgement for helping us get where we are today in terms of applying this technique and taking ourselves forward. But I also want to acknowledge evolution. There's not many groups out there that will support you to orientate your techniques and understand how to apply the best exploration techniques in an area. And what we are committed to doing is applying it and delivering back to the company that big regional game changer, whether it's around Red Lake or any of our other exploration projects. If you're going to do this type of work, ODM for us, overburden drill management, were absolute key for us in terms of supporting delivery, but also sample analysis. And so greatly enjoyed working with them, and they supported us and guided us a lot, even to this day, in terms of how we apply this technique. And I touched on it in the presentation, but Don Cummings, he's the absolute pro. And I think we could have wasted a lot of time and effort and done quite a bit of navel gazing if we hadn't engaged Don really early in the process here to help us understand and get ourselves up the curve on glacial history. I've referenced a bunch of material in this presentation. I haven't got the list here, but if there's anything that you're interested in reading more about or understanding, please just contact me directly and I can either supply the references or supply you with the material where it's been based off. So Jess, that's it from me. That's my time in Northwest Ontario.
That was awesome. Thank you so much for sharing that with us. I really appreciate it.